Hello, grade 8s. Here's a lesson on square roots of a number. So before we learn about square roots, you have to look at what's called a perfect square. So drawn here in number 1, I have drawn the first 4 perfect squares using kind of the grid shape. So we have this square, which is 1. It has 1 square. It has an area of 1. You notice this square has 4 squares, so it has an area of 4. This square has an area of 9, and this square has an area of 16. So you notice that these are the first 4 perfect squares. You can't make a perfect square with anything in between these, like 3 or 6 or 12. You would have imperfect squares. So continuing with that, so if this is an area of 1, this square is 1 unit long by 1 unit wide. It's a 1 by 1 square. This is a 2 by 2 square. This is a 3 by 3 square. And this is a 4 by 4 square. So you kind of make the connection right away that square number 1 is 1 times 1. Square number 4 is 2 times 2. 9 is 3 times 3. 16 is 4 times 4, and so on. So that allows you to make a connection in finding the first 15 perfect squares, because that's what we ask you to memorize. We ask you to memorize the first 15 perfect squares. So you basically just continue with that pattern. So 1 is the first, 4, 9, 16. So now we just keep going. That's 1 times 1, 2 times 2, 3 times 3, 4 times 4. Next one's 5 times 5. Then 6 times 6, 7 times 7, 8 times 8. 9 times 9, 10 times 10. From here, it gets a little bit trickier, but it can be done. Every year I ask students to remember the next 5, because that's the first 10 here. So we go 11 times 11 is actually 121. 12 times 12, 144. 13 times 13 is 169. 14 times 14 is 196. You notice how they reverse the 6 and 9 reverse. And finally, 15 times 15 is 225. All right, so that's the first 15 perfect squares, and I like students to memorize those. Okay, next, so here's a connection I want you to make, right? So the first square was 1 times 1. That's another way to say that is 1 to the power of 2. Because there's 2 1s. That's where the exponent 2 comes in. 2 times 2, 2 to the power of 2. 3 times 3, 3 to the power of 2, etc. And another word for, again, to the power of 2 is squared. So 1 squared, which is 1. 2 squared is 4. 3 squared is 9, etc. So you can see when we run all the way down, all of our first 15 perfect squares, we've already made this connection, correct? So in other words, I wanted you to show you something else. Look at these numbers here. So what we have then, if 1 times 1 is 1, that means that the square root of 1 is 1, we say. And the square root of 4 is 2. The square root of 9 is 3, and so on and so on. So you can see that square root and squaring is opposite. Here we're squaring. 1 squared is 1, 2 squared is 4. Here we're doing something called square rooting. So the square root of 1 is 1. Or in other words, if you have a square that's 1 and you square root it, it's 1 long. A square root, the square with the area of 4 has a length of 2, or the square root is 2. A square root of 9 is 3. A square root of 16 is 4, etc. So there's a connection between squaring and square rooting. They're the exact opposites of one another. This and this, they're the exact opposite. All right? So that makes a connection here of the following. So that first square had an area of 1, a length of 1. The second square had an area of 4, length of 2. This one had an area of 9 and 3 and 16, 4. Right? Basically, we're looking back to this. All right. So that's where the connection's made, right? To find, if you know the area of a square, you just square root the area and it will give you the length. It will equal length. Square rooting area equals length. So if I said to you, I have a square with an area of 100 meters squared of area. And I said, how long is this square? You would simply take the square root of 100, which we know as 10. But the units are no longer squared. We say that this square is 10 meters in length. And that's what square root does. It allows you to find the length of a square when you know its area. Okay? Using a calculator, it's very simple. You can do it kind of, you'll see mentally, or you can just do it with a calculator. So if I asked you, what is the square root of 48? In other words, I'm looking for what times what is 48, right? Some number times the same number equals 48. So I know, it could be it's not quite 6 times 6, it's more than 6 times 6, which is 36, or it's less than 7 times 7, right? Because 6 times 6 is 36, 7 times 7 is 49. So if I was to do an estimate, I know that it's between 6 and 7, probably closer to 7, right? But how you can do it on a calculator, you just simply press the number, and then there's a square root symbol, and that often just works. So maybe your calculator, you must press the square root first, then the number, and then equals. That's kind of what you need to do. Okay, so when you square root 48 on your calculator, you press whatever way that your calculator works, square root 48, and I know the answer will be somewhere along the line of 6.9-ish, just making an estimate. If you were to use a calculator to get the square root of 185, I know that it is between the square root of 169, which is 13, and the square root of 196, which is 14, right? So again, I know that it's going to be somewhere in between. It's about 16 away from here and about 11 away from here. So it's probably closer to 14. So, estimating it myself, I'm going to guess 13 point, probably 7, something like that. And you can use a calculator though and get that answer right away. Okay, which leads us to estimating, which is very, very important in grade 8, the ability to estimate without using a calculator. So here we use a number line. It's called a square root number line. So when we square root 1, we get 1. Square root 4 is 2. 9 is 3, etc. You line it all up like so, and that gives you a nice, easy visual if I was to estimate square root 15. So when I look at square root 15, I know it's between here and here. I know it's between the square root of 9 and the square root of 16. So in other words, I know that the answer is between 3 and 4. But I know it's closer to 4, right? I know it's between 3 and 4, but 15 is so close, so I'm going to guess 3.9 is your estimate, right? And that's kind of how you estimate and show all your thinking. So estimate 3.9. For 83, square root 83, I know it's between the square root of 81 and 100. So between square root 81 and square root of 100. But in other words, I know that the answer is between 9 and 10. But I know that it's closer to 9 because it's just past 81. So I'm going to take a guess. Something like 9.14 or something like that. So my estimate, maybe even less. I'll stay safe and go 9.1. So you want to try to get as close as you can. So another one, square root of 154, the very last example here. 154 is tricky because we know it falls somewhere in here. I know it's between the square root of 144 and 169, which means that I know it's between 12 and 13. Right? I know it's between 12 and 13. Now, where is it in relation to these? Well, I know it is actually 10 away from this, and it is 15 away from this. So it's actually closer, 10 away from this, 15. So it's closer slightly to this one than it is to this one. It's still 15 away from 169. So it's actually closer to 12. Just by a bit. You got to kind of do your math there. So it's closer to 12, but it's not going to be low. It's not going to be 12.1 because that's 144. So you kind of got to guess it's got to be slightly under 12 and a half because 12 and a half is right smack in the middle of these two. But since it's closer to 12, you got to guess 12.38 or something like that. And that's my estimate. Okay, and that is how you use square root.